Hi, come on, internet connection. Okay, so what about this time? You can see now.
Yes po.
Okay, so we're going to discuss the Boyle's Law. Actually, we're done with this pretest, no? Okay, so here we go. So just like what I told you last time, no, the general properties of gases, we have gases have no definite shape and no definite volume as well. Gases diffuse very rapidly. Okay. So when we say diffuse, diffusion means it is the tendency of gas particles to move toward area of lower concentration until the concentration becomes uniform throughout the system. Next, we have gases can readily be compressed. And we have the gases have densities much lower than those of solids and liquids. That's only a short review. Okay. So with the general properties of gas, we have the mass, volume, temperature, and pressure. When we say mass, it refers to the amount of matter in an object. What's the unit for mass? 10A. The unit of mass is in the standard unit system. What is the unit of mass? Yes, Roy. Roy, what's the unit of mass? Okay, Francis. Last number 17. What's the unit of mass?
Gram po.
Okay, gram or, yes, Akira, you're raising your hand. Gram or, what's the unit of mass? That's only unit. Unit. Ano po ang unit ng mass? Ha? Yes, Frances, you're raising your hand. Francesca?
Kilogram po.
Okay, that will be kilogram. So kilogram or gram. But if we're talking about the SI unit, then that will be kilogram. What about for volume? What's the unit for volume? Huh? Abby, what's the unit for volume?
V po. Ay,
Volume. Okay, that's the symbol, letter V. But I'm talking about the unit. What's the unit for volume? Jody.
liters po.
Okay, liters. Very good. Then what about for temperature? What's the unit for temperature? Yes, Kate. Temperature
Celsius po.
is
Kelvin.
and
Kelvin.
okay, Celsius, Kelvin, and the other one is
Fahrenheit.
Fahrenheit. Very good one. Okay. So thank you so much, Kate. Okay. For volume, you said it can be liters, can be also milliliters. When we say volume, it refers to the amount of space occupied by the gases. What about the temperature? When we say temperature, it is the measure of the coldness and hotness of the gas. Temperature can be what? Measured using the unit of degree Celsius, degree Fahrenheit, and Kelvin. In the gas law, no, or gas laws, the one that is used here is Kelvin and degree Celsius. That's why you should know how to convert the degree Celsius to Kelvin or vice versa. Pressure. When we say pressure, it is the force applied by the gas particles per unit area. And what is the unit for pressure? The standard unit for pressure is what?
PSI.
Okay, PSI or pounds per seconds. What else aside from PSI?
Atmosphere.
Atmosphere or what we call the ATM. Okay, that's the one. Any other unit for pressure?
Pascal.
Pascal or PA. Very good, Denzel. Denzel, may I see your face? I cannot see your face. What else? Huh? So we have Pascal. We have kilopascal. Oh, still Pascal, that one. What else? Huh? Yes, Eric. Class number 7.
I
We
don't
have,
know.
you don't know? Huh? John Adrian. What's the other unit? So we have pounds per seconds. Okay.
Millimeters of
Okay.
mercury.
Again?
Millimeters of mercury.
Millimeters of mercury. Very good. Or mmHg. So those are the units. So don't forget that one. Okay? So let's proceed. When we say barometer, it is the instrument or an instrument measuring the atmospheric pressure. And the one who invented that is Evangelista Torricelli. He is the inventor of the barometer. So let's talk about the gas laws. The first gas laws that we will talk about is Boyle's law. Okay? So what do you mean by Boyle's law? Anyone from the group who can give me what is the pictures of this Boyle's law? Huh? Yes, Sarah. Huh? What can you say about the Boyle's law? Sarah?
Me po,
Yes. Sarah
uh,
number 23.
pressure and volume are inversely proportional.
Okay, so we have pressure and volume relationship. If we're talking about Boyle's law, very good. So meaning to say, pressure and volume is the given here. Okay, so in the gas law, it's explained the relationship between the properties of gases. Okay, so next we also have it helps to predict how gas will react if pressure, temperature, or volume is changed or kept constant. Okay, so let's not have this one already because it's already there in your okay. So here we have the pressure volume relationship, which is the Boyle's law. So just like what I told you a while ago, we will use the pressure and the volume with regards to the standard units, no? Okay. So for our objective, there we have to investigate. Okay. Later that one. Okay. The activity. So with this Boyle's law, okay, it was investigated, but whose scientists? Hmm? Who investigated this Boyle's law? Hala, ayan na nga. Ayun. Robert Boyle, very good, Antoinette. It's already there, no? So Robert Boyle is the one who investigate the Boyle's law. But before we go to that one, let's talk about the gaseous sample or the different quantities that we will use for the gas law. Okay? So the following units that we will use for the gas law is the amount of gas, the temperature, pressure, and volume. The one that we talked a while ago. Okay. So here, since Boyle's law, no, you said volume pressure relationship. What is the relationship of this pressure and volume? Hmm? What is their relationship regarding with the pressure and volume? Anyone from the group? What is their relationship? Mhm. Ala,
The
parang
larger
hindi.
the volume, the lower the pressure.
The larger the volume, the lower the pressure. So meaning to say, Mr. Archileta, their relationship is what? Hmm?
Proportional.
What kind of proportional?
Not sure na, sir.
Huh?
Not sure
What?
na.
Not sure na. Okay. So because according to Archileta a while ago, if the pressure increase, the volume decrease or vice versa. If the volume increase, the pressure will decrease. Now, what kind of relationship is that?
Sir, try.
Yes, Gian, Villena?
They are inversely proportional.
Okay, very good. They are inversely proportional. When we say inversely proportional, meaning to say what? Hmm? If it is inversely proportional, what do you mean by that? Yes, Lara. So the relationship of volume and pressure is inversely proportional. So meaning to say what? Maynard. Huh? What do you mean by inversely proportional? I just said a while ago eh. Yes, Mackenzie, you're raising your hand. Oh, what is the relationship between the two? They said inversely proportional. What do you mean by inversely proportional? Yes, Gab, Biteng.
If one increases for the other one decreases.
Very good. Isn't it? I said already a while ago, if the pressure will increase, what will happen to the volume will decrease. And then if the pressure will increase, what will happen to the volume is decreasing. So you have to remember, that's why inversely proportional. Mackenzie, you're talking to someone? You want to talk? Okay. So that's the meaning of inversely proportional. Always remember, Boyle's law is an inversely proportional relationship. If the pressure will increase, the volume will decrease. And if the volume will increase, the pressure will decrease. Gets? Question about relationship of Boyle's law? None? Okay. So can you give me the formula for Boyle's law? What's the formula for Boyle's law? Anyone from the group who can give me the formula for Boyle's law? What is the formula? Halak ka. What's the formula for Boyle's law? No one can give?
Sir,
Yes, go ahead.
pressure sub 1, volume sub 1 equals to pressure sub 2 and volume sub 2.
Okay, very good. Just wait, I'll change my camera. I'm sorry. So for Boyle's law, we have the formula
Sub
is
1 po, P sub 1 and
P
V
sub
sub
1,
1
okay, and B sub 1,
equals to P sub 2
P
and
sub
V sub
2, and B sub 2. Okay, is it visible my handwriting? Huh? Okay, now, what if P1 is unknown? P1 is the one unknown. So meaning to say, if P1 is unknown, then the formula is what? What's the formula for P1 if that is unknown? Anyone me? Who can give me? What's the formula for P1 if that one is unknown? Huh? Yes, Jello. What's the formula if P1 is unknown? Jello, you can hear me? Let me know if you can hear me. If you don't know the answer, please tell, sir, I don't know the answer so that we can move on. Okay? Oh, any other question? Anyone who could give me the formula for P1? Luis, you have the idea? What's the formula for P1? Yes, Luis? You don't have? Okay, anyone who can get the formula? Yes, John, Adrian.
P1 equals P2 times V2 divided by V1.
Very good. Divided by V1. So that will be the formula. Okay? So how did you get that one, Sir Alex? So how did we get that one? From the given formula or from the general formula, since P1 is unknown, what you will do is divided by both side by P1 times B1. So like this. Okay, so here's our first formula, ha? Okay, P1 times B1. Okay, so for example, P1 times B1 is equivalent to P2 times B2. Sir Alex said, if P1 is unknown, then we need to divide it both side by what? P1, okay, or B, P1, sorry, B1. Okay, and P1. Okay, so P1. Just wait. Cancel, cancel. Then after that one, P1. Okay, so B1, B1. Then we can get already the P1. You can see, ay, wala palang nakikita. Sorry po.
Sir, can I
Yes
go to
po.
the comfort room po?
Go, 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 go. Okay. Please wait. I'll get another paper po. Ha? Okay. Just wait. Ako lang nag-solve. Hindi nyo nakita. So, hello. So, I'm so sorry because I'm the only one who's solving. Okay. So, going back, I hope it's visible. So, we have P1 times B1 is equivalent to P2 times B2. Okay. Sir Alex is asking about the formula for P1. And Archileta said we have P2 times B2 all over B1. Okay. The best cue here, no, so that it will be easy, okay, you just cover this one, the P1. Then what you will do, this B1, you will put it under the P2 or P2 times B2. Okay. Same with the other one. If B1 or if B1 is unknown or this B1 is unknown, then the formula is P2 times B2 divided by P1. Okay? You get the point so that it will be easy? Ha? Uy. Ano eh? Okay, let's try. What about the P2 is unknown? Okay, if P2 is unknown, the formula is what? What's the formula? Anyone who could give me? P2 is unknown ha, P2. Hala ka.
Sir,
Yes,
try po.
Nathaniel.
Is it ano po, P1 times V1 over V2 po?
Sorry, I'm muted po.
Okay, so we have P2 is equivalent to P1 times V1 over V2. What about V1 is unknown? What's the formula for V1? Huh? Hello?
Sir, may I try?
Yes, go, please.
P2 times V2 over P1.
Come again.
Um, P P sub 2 times V sub 2 over P sub 1.
Okay, very good. Then we have already the formula for B1. What about for V2? Okay, or B sub 2 or volume 2. Who can give me the formula for V2? Anyone from the 10A who can give me the formula? Oh, you can use your microphone. Go. You can turn on. Volunteer. Who
Can
can
I
give
try
me the
po,
formula? Who's that one?
Aldea?
Aldea. Go, Aldea.
V sub 2 is equal to P sub 1 times V sub 1,
All over.
P sub 2.
Okay, we have P sub 2. Very good. So remember, we have already the so that you will not be problematic. I know this is your problem in deriving the formula. You have your formula for P1. Here is it already. Formula for P2. And you have your formula for V1. And also, you have the formula for V2. This is the B2. Is it clear already? Huh? Gets? So we can solve it already since you know already all the given. If the P1 is unknown, if the B2 is unknown, if P2 is unknown, if V2 is unknown. So let's get it on with the problem. But before that, no, let's try to answer this given formula. Oh, okay. Look at this one. Trier 1. Okay, pressure relationship at constant temperature. So meaning to say temperature is not changing. Okay? So you will just multiply. 3 times 24, what's the answer? Don't have P1, P2. You just multiply that one. Okay, this is 72, 72, and 72, 72. No need, that's experiment. Okay. So as you can see here, the graph of Boyle's law is known as the pressure volume graph or PV curve. Okay, but when we say PV curve, look at the figure on the side. So the curve is called the PV curve and it is hyperbolic in nature. Meaning to say, as the volume increases, what will happen to the pressure? Sorry, it's wrong. Okay, as the volume decreases, the pressure increases. Okay, and then as the pressure decreases, the volume increases. Okay, so that's the one. Okay, thus pressure and volume relationship is inversely proportional. Okay, so Boyle's law stated that the volume of a gas is inversely proportional to its pressure and at a constant temperature. And what is the constant temperature? That is 273 Kelvin. Okay? So, let's wait. The next we have here, no? So it means that the pressure, or as the pressure increases, the volume decreases, and as the pressure decreases, the volume increases. Okay, so who is this one? Huh? This is Boyle's law. Okay, not Sir Alex, that is Boyle's law. Okay, or that is Robert Boyle. Okay, so let's get on. This is Robert Boyle. Okay, and he's the one who investigate this Boyle's law. So just like what you said, for V1 or for the Boyle's law formula, P1 times B1 is equivalent to P2 times V2. Okay, where P1 is the initial pressure, P2 is the final pressure, V1 is the initial volume, and your V2 is final volume. Are you following 10A? Okay, so let's get it on. So you need to be used here. Of course, you're using volume, so you can use milliliter or liters. But as much as possible, if we are talking about gas law, you use ml or milliliters. Huh? So if the given is liters, okay, then convert it into ml. But for example, the first volume is ml and then the second one is liters. Then use ml. But if both volume are liters, no need to convert anymore. Okay? Next, for the unit of temperature, actually, we will not use anymore the temperature in Boyle's law because according to the statement here in the Boyle's law, what is that? The temperature is constant. So meaning to say, we will use only the volume and the pressure. Let's talk about the unit of pressure. So you have your Pascal, atmosphere, millimeter of mercury, bar, torr, pounds per second, or square inch. Okay? So in the standard temperature and pressure, okay, very noisy. Okay? For the STP or standard temperature and pressure, the standard temperature is Kelvin, which is 273. My dear, we will not use anymore the 273.15. Remove already the 0.15 so that we will not have points anymore. Gets? Huh? So just follow 273. Okay? And for pressure, the standard pressure is will always convert into atmosphere. So if the given is millimeter of mercury, then use or convert that millimeter of mercury to atmosphere. Gets? Question. None? Then A. No question? Okay, let's get it on. Let's proceed already with the first problem solving. Okay, sitting there, a scuba diver needs a diving tank to provide breathing gas while he is underwater. How much pressure is needed for 6.0 liters of a gas at 1.01 atmosphere to be compressed in a 3.0 liters cylinder? Okay, so let's try this one. Okay, I'll change my camera again. This is my problem because I don't know how to use the, what's the other camera? There. So, going back to our given, no, what are the given in problem number 1? Okay, you can use your microphone. I will turn on already the uh, messages. But please, if you know the answer, you can use the microphone because you keep on using the chat box. So what are the given in this problem? Huh? 10A. Oh, see, you're not talking. So we have 6. What is that 6 liters of gas? Hmm? What is that 6.00 liters of gas? Oh, yeah. I know that's volume, Nathaniel. But what is that? Is it V1, V2? Huh? Okay. Antoinette, according to Antoinette, what's your answer?
Volume 1.
Okay, the 6.0 liters is the volume 1. Very good. So for your B1, that will be 6.00 liters. What about for the other given? Who can give me? Huh? Use your microphone. Cyril. Mama Riel, what is the other given? Hmm? Cyril.
3 liters.
What is the 3 liters?
Volume 2.
What kind of volume? That will be
Volume
V2. Okay, what else? Huh? What else are the given here? No more? That's only the given?
1.01 ATM po.
What is that 1.01 ATM?
Pressure 1 po. P1.
Pressure 1. Okay, we have our P1. That will be 1.01 atmosphere. So what is unknown in the problem? Huh? The unknown in the problem is, very good, Akira Gabjian, no? P2 is unknown. So if P2 is unknown in the problem, then what is the formula for P2? Huh? What's the formula for P2? Carl, Justin. Carl, what's the formula for P2 again?
P sub 1
P sub 1
times
times
B sub
B
1
sub 1 all
divided
over.
by B sub 2.
Very good. P sub 1 times V sub 1 divided by V sub 2. Okay? Gets? Can we proceed now? So what we will do this time, our P1 is, what's our P1? Huh? Mackenzie, what's our P1?
1.01 atmosphere.
Okay, we have 1.01 atmosphere. What's our B1? Huh? Reynard. Roy, what's our B1? Roy?
6.00 liters.
Okay, we have 6.00 liters divided by, what's our B2? Huh? What's our B2? Luis, what's our?
3.00 liters.
Thank you so much. Okay, we have 3.00 liters. So at this moment, what we will do is to cancel the what? Liters. So cancel this one and cancel this one. Teacher, are we going to convert the liters into ml? No need, because both of them are liters already. Gets 10A? But if this one is ml and the other one is liters, then that's the time that you need to convert the liters into ml. So we can now proceed with the computation. 1.0 atmosphere multiplied to 6.00 divided by 3.00, then your P2 is now, what is our P2? That I'll put here. P2 is, go, go, go. What's our P2? Who can give me the answer? You're using again the chat box. Okay,
0.02 atmosphere po.
0.02?
Ay, 2.02.
Okay. There, Gab, ha? Okay, we have 2.02 atmosphere. Okay, what happened to my letter M? So this will be your answer. 2.02 atmosphere. Anyone who got the answer? 2.02? Okay, very good. At least we're on the same track. No? Okay, so here, the 6.0 liters and the 1.0, these are the given. No? So there you go. Ito is unknown. There the formula. Problem solving number 2. Let's get it on. Problem solving number 2. I want that all of you will answer in the chat box. I don't want that you will copy, ha? So problem solving number 2. The volume of air in the marshmallow blaster is 450 ml. The pressure is 1.00 atmosphere. What will be the new volume of the new pressure, which is 9.00 atmosphere? Okay. Proceed. I don't have scratch anymore. Okay, Pawi, would you mind to give me what are the given in the problem? 450 ml, then okay, then 9.00 ATM. Very good, Pawi. Back to you, Pawi. What's the unknown here? Okay, B sub 2. Very good. Okay, because it's written in the problem, what will be the new volume? So you're looking really for V2. And what's the formula for V2? Yes, Nathaniel. Class number 19?
The formula for V2 is P sub 1 times V sub 1 over P2 po.
Okay, very good. Over P2. Okay. Then you can substitute already the value of P1, V1, and P2. Okay. So we can substitute. Our P1 is 1.00 atmosphere multiply to what's our B1? That will be 450 ml all over 9.00 atmosphere. So at this moment, what we will do is to cancel this atmosphere and this atmosphere so that we can proceed with our computation. So what will be the value of B2 now, or the new volume? Compute. You can type your answer in the chat box. 50 ml according to Jake. Okay, and the 50 atmosphere to Francesca. Maybe typographical the unit because we already canceled the atmosphere. Remember? Okay, so very good. Most of you got the answer 50 ml. Okay, nice one. So 1.00 times 450. Sir, no need to convert the ml to liter. No need. Okay, because it's already ml. Sir, you said standard unit. If in the problem stated that convert the volume into or convert the volume to liters. Okay, that's the one. Kuha ba? Question. Who among you converted the 50 ml to liters? Did you convert into liters? Huh? No one who converted the ml into liters? Meow. Okay, Nathaniel, you converted this one into liters. And what's the value? What's your answer, Nathaniel? That's 0.05. Oh, 0.05. What's the unit? Nathaniel, use it properly. Okay, 0.05 liters. So always remember to put the what? The unit. Because if no unit, that is equivalent to what? 0.5 only. The value or the points if I will check. Don't forget the unit. Okay? You have to call girlfriend or boyfriend. Cannot be jowa or shota. It's not good if you're calling shota, isn't it? Okay, that's why you have to put the correct unit of the numbers of your answer rather. Question? None? Let me see if we still have another. Okay. What about this one? Teacher, may pa times 10 raised to 4 ka pa, ha? Okay. So number 3, neon, which is has the symbol of Ne. Okay. So our neon sample occupies 4 liters at a pressure of 5 times 10 raised to the 4 Pascal and 273 Kelvin temperature. Calculate the volume of the sample at STP. Okay. Hala ka, teacher, why it's lacking the given? Let us see if you can answer that one. So what are the given in the problem here in number 3? Huh? Anyone who could give me the given? Yes, Antoinette.
4 liters.
What is that 4 liters?
The B sub 1.
Okay, B sub 1. What else?
5 times 10 to the 4th Pascal.
Okay, that will be 5 times 10 raised to the 4th Pascal. And what is this?
The P sub 1.
P sub 1. What?
273 Kelvin temperature.
about